Hello, welcome to episode 24, which is the introduction to the fourth course outline we outlined in the beginning, the first episode. This is going to be motion along inclined planes or motion up and down the inclined plane. I may not get into details of this because under mechanic statics, when we talk about frictional force, we talk about these type of forces along the plane. So I'll just pick some information from that tutorial and to lay the foundation for what we actually need here, because we are dealing with what? Motion. So we'll be dealing with the equations of what? Motion. So if an object is placed on an inclined plane, the journey of the object, if it is moving upward, the journey of the object is going to be this plane. So if it is here, it is coming down. If it is going to move up, it is still going to move this up. The distance it is moving is here. The inclined plane, the distance traveled by that object, either upward or downward, is going to be this h. Then the force acting on it is going to be parallel. That's what we have for parallel force. Then there is also a force perpendicular to the surface, which is going to be perpendicular force. Then this force we are seeing here, which used to be the weight, the only force acting on the body is the weight of the body. The weight of the body itself. That is the one we are seeing here, the force of gravity acting in this way. Now, when a body is placed on an object, there is a force acting upward towards, away from the object. That is what we call what? The normal reaction. So this is also going to be a force out there which we can call the normal reaction. And that normal reaction is also moving what? Upward. You can see it's moving up, down. It is also perpendicular to the surface. Then with this, I am picking this first in the case of the plane is going to be smooth. The plane can also be rough. It can be a rough surface. It could also be a smooth surface. So my first analysis are all going to be made on smooth surfaces. So when a body is smooth, it means that frictional force is going to be negligible. There will be no friction on the surface. So I ignore that. So I'm going to focus on this as a smooth plane. If I can indicate somewhere as smooth plane. Good. So on a smooth plane, the frictional force is going to be negligible, right? All right. Now, if we pick this from the episode we did in the static, you know that when the plane is on the ground, when you raise it, as you are raising it, the force of gravity at the center of it will be displaced. The moment you begin to raise the bar up, it's creating an angle with the surface or with the ground. As it is raising, the same way the center of gravity will be shifting away from the center. It will be in line because it will be vertical. So as the body is moving, you see that the body is no more going to have that direct movement. It will be shifting away. That shift is going to be equal to the angle that the plane is making. Hence, this angle is theta, this angle is what? Theta. That's why the two angles are the same in there. Now, if I can have another line parallel to the parallel one we are having there, let me have it this way. So if that is parallel, this will give us a right angle triangle, where here will be what? 90. So I can pick that out from there. Let's see if I can pick it out and redraw it this way. I'm drawing too big, but so if I have this vertical line we are seeing here is going to be also vertical. So here is going to be R. Then the movement down here, this is going to be this line. As we can see, this is going to be the weight. You see, this was like this. As you can tell, it's like this line we are seeing here, which is the weight, is going to be here. Then this line is going to be parallel to the force. This is the force, parallel force, so I can label that. This is going this way. So we have the force, This is coming down. This is also coming down. So we have this. This is the angle we have in here. So I can use this as the cos of this. So we can only say that from, can I label it? This is going to be, okay, let me just say from the diagram. What am I going to do? I want to use the cos. So this is going to be, the cos of this is opposite adjacent hypotenuse. So that is going to be cos theta equals to the adjacent side, which is r, divided by what? The hypotenuse, which is going to be the w. I guess that is clear. If I do that, what am I going to do? If I cross multiply, r will be equals to w cos theta. What is the r? It is the force which is perpendicular to the plane or to the surface. This force, as we are seeing here, that is what we are having as the normal reaction. And this normal reaction can be given as W, which is the weight of the body, times the cos of the angle made with the ground. Which this is the same as this. So that can also be R equals to mg cos what? Theta. Let me label this as what? Equation 1. So here I'm using the cos to find that normal reaction. And I can also use the sine to find the force parallel to the plane. So what will I do? I can say that the sine of the angle theta equals to the opposite side, which is going to be F, divided by the hypotenuse, which is also going to be what? W. So in the same way, if I cross multiply, the force will be equals to W sine what? Theta, which is the same as the force equals to mg for W, then the sine what? Theta as the second word equation. So these are the two equations we can get in terms of finding the normal reaction and the force parallel to the plane. So any force going this way is going to be mg sine theta. The force coming here will be mg cos what? Theta, which is what we are having in this place. All right. Remember, we are still taking into account a smooth what? Plane. All right. Now, if a body is placed on the surface, you can see that the force of gravity, which we know pull objects towards the center of the earth, the full force or the full potential force is not going to be applicable because the body is no more vertical, or let's say, yeah, it's no more vertical on the ground for the force of gravity to act on it. Which means the force of gravity is going to be divided. One is going to pull the object along, as you can see the G is there, and the other is also going to be the one pulling the object perpendicular to the surface. But you can see, since there is no movement, this one is going to be negligible. Then we can consider this as the force of gravity, the only force of gravity acting on the body, the one that is causing the body to slide down or when released to move down. I guess we are listening to that aspect clearly. So that means that if I want to resolve some forces, I can also say that this is normal reaction. There will be a force acting against the body upward, which is normal reaction, which is going to be bigger than the negligible force of gravity we are talking about. So I can say that this minus this, if I subtract this from this, it is going to be 0 in order to keep the body at the position there. So if we are making that resolving of that force, which is going to be perpendicular to the plane, is going to be this minus this equals to 0. Then when you take the negative to the other side, it gives you back to what we are seeing here. So this is for perpendicular forces. Now, what will be the acceleration of the body? The acceleration of the body is the force that is going to pull it down. So I can say that if I have the force, which is the same as this is the force, the parallel force pulling the object down, is the mass times acceleration. Then the force we found, where is it? The force we found here is also here. So I can say that, can I say equation 3 equate equation 2 and 3, force. I can say that MA equals to mg sine what? Theta. Whereby mm is common, so the acceleration is going to be g sine what? Theta. So if I'm looking for the acceleration, that is, remember you're talking about motion, the acceleration of the body as it is being moving down is going to be the force of gravity times the sine of the angle the inclined plane make with the ground. So this is the acceleration. So now it means here we can now think about the equations of motions that can be applicable. So how do we do it? Let's find equation of motion. Let's see, okay, equation of motion, the three equation, the alteration of that for a body which is moving down an inclined plane. You see, if this is the inclined plane, I should have this is coming down. I know this is going to be the height I'm looking for. Now, when a body is coming down, the acceleration is going to be positive. It's moving in line with the acceleration itself. Remember, we talked about the force of gravity that is going to act on the body is divided into horizontal and perpendicular. The horizontal one that will cause the body is the acceleration, which will be in the same direction of the body. Therefore, g, what is it? Sine theta. That is going to be the acceleration. So if the body is moving down, let's say I have this. This is moving down. So theta. I'm just replicating one of these in here. We can now alterate the equations of motion as the first equation. Let's see. Let me clear here so that we move on that. So from here, we can say that the first equation is going to be V equals to U plus AT. Remember? U plus AT is the equation of motion. Then the A is now known to be this. So I'm now going to replace this with G, where is it? Sine theta times what? T. Or I can only say gt then sine theta. You can also decide to maintain V equals UAT. Before you use that formula, you will have to first of all find the acceleration of the body using this. So no need to do substitution. That is also clear. Find the acceleration, substitute, or remove the A and put this directly. The second equation, which we know to be S, equals to UT plus half AT what? Square. I am writing it first before we remove the A is now going to be G sine theta times what? T squared. So let me put this in a bracket. You solve this, multiply by half, go that side. Then equation 3 is V squared U squared plus 2A what? S. So A is going to become G sine theta multiplied by what? S. So this is the equation of motion. Remember, it is not compulsory to quote this. What you need to know is that I need to find the acceleration first using this, then I use a normal equation that I'm following. So this is what we are going to have when the object is on a smooth plane. On a smooth plane, we deal with this. Now, if I'm looking for the time, I go to this place. Then if I'm looking for the time it takes to reach the height, the maximum height, the time it takes, your final velocity will be 0. Then you find that. In order to find the maximum height reach, if you're looking for the maximum height reach, the velocity will be 0. We can use this. Or you substitute the time into this to find the distance. It's the same. All right. Now, how about we have a rough plane when the inclined plane is what? Rough. Let's see. Let's make a sketch of that. Okay. This is going to be h, the height. Let's have the body. Okay, let me use this. So this is going to be the width. This is going to be the normal reaction. is going to be a friction, and this is going to be the parallel force. So there's a force moving in this direction, and there's going to be a friction also moving, causing the body not to go. So our mg sine theta will be here, since theta is here, then the frictional force is going to be there. So as the body is moving or accelerating down, the force of gravity will cause it not to what? To move. Right? The force of gravity will be causing it not to move. So I can say that this is moving down, this is what? Moving up. But the moment this is more than this, the body begins to slide down. Right? Okay, so what do we do? What can we use? I think we also have mg cos theta here. What again is that? Now, if you look at this carefully, we are going to have the frictional force is going to be limiting. So our frictional force is going to be equals to the mu times what? Normal reaction, from the principles we have in the static equation that we did, the static tutorials. So we can say that the force that will cause the body to move down will be the one that is going here must be bigger than this before the body will move down. When both are the same, the body is going to be on a rough plane. So we can say that the force that causes the body to accelerate is going to be the mg sine what? Theta minus what? The frictional force. The frictional force that is pulling the body out then. Now, we have limiting force, limiting friction, limiting friction is F equals to mu, that's what? The coefficient of what? Friction times what? The normal reaction. This is being derived from the episode under static, mechanic static. All right. Now that we have this, we can easily substitute the F by this. So let's clear here and see what we can do. So from here we can say that our resultant force, the force that is going to be the one making the object to finally accelerate, is going to be our mg sine theta minus F, which is now coefficient of what? Friction times what? The normal reaction. Let's see, we can also remove the R, but your R is also equals to, what is that? That is mg cos what? Theta. As in the normal reaction we are having here minus the force of gravity moving down. If we subtract that, that will give us what? 0. So if you do that, we get this. So this means that the force, which we know to be ma, equals to mg sine theta minus coefficient of what? Friction times the normal reaction, which is also mg cos what? Theta. If we divide through by m, you'll be having acceleration left equals to g is common, so I have g out, the sine of theta minus this cos what? Theta. So this means that the acceleration that I need when the body is on a rough plane supposed to be calculated using this, when the coefficient of friction is also provided. Then the angle, we have it here. This is what we are going to be making use of. We can substitute this directly into these equations in order to make it a new equation. But I'm going to leave this one like this. Find the acceleration, then use your VU plus what? AT directly, where the A is these values we have here. I'm sure you are getting the concept. You take your time and assimilate the information, because that's from the basics of what questions we'll be solving on the way. All this is still on smooth plane. Okay, this is on what? A rough what? Plane. And all this is talking about the body is what? Sliding down. So equations of motion of a body, that is what? Moving down the plane. What happens when the body is also moving up the plane? And this we will consider only the smooth movement. I will not consider the rough plane. I will consider the smooth plane. So let's clean and start all over again for a body moving upward the plane. Okay, so now let's see. Equation of motion of a body moving up inclined plane. So if the body is moving up, it means that the acceleration of the body is not going to be in the same direction as the acceleration of the body. As the force of gravity, sorry, as the force of gravity. So the force of gravity is moving along the plane, down the plane, then the body is going to move forward, up the plane. That means that the acceleration is going to be negative of what? The gravity, which is sine what? Theta. Remember, this is going here is g sine what? Theta. That is the acceleration moving down. But moving up will be negative. So your force equations will become V equals U plus what? AT, which this is going to be negative G sine theta what? T. So let me bring the T before. Then your second equation will also be S equals to UT minus half. That will be G first. So G sine theta times what? T squared. And finally we have V squared equals to U squared minus 2A, which is sine of the angle multiplied by what? The distance. So this is to tell you that if the body is moving up, your force of gravity is moving in opposite direction. Therefore, the acceleration becomes negative of the gravity. And in the inclined plane, the gravity take the sine of the angle the plane make with the surface. I believe this gives a clear picture of motion along the inclined plane, which is moving up the inclined plane and moving down the inclined plane. This will be the end of it. In the next episode, we'll pick question to text all that we have done in this episode. Don't forget to come back, like, share, comment, and subscribe.